We were discussing the vector equation of a line. Vector equation of a line, okay? We were on exercise 6b, so we will start with our question number 1. It says, find the equation of line. Find equation of line, vector equation of line. Find vector equation of line. Find vector equation of line passing through A 2, 3, 5 and B minus 7, 1, comma 6. Okay, find equation of line passing through A 2, 3, 5 and B minus 7, 1, 6. Okay. Now this is the line whose equation is to be searched for, and this line passes from 2, 3, 5, and this line passes through B as well, minus 7, 1, comma 6. Now AB will act as a direction vector. AB will act as a direction vector for this line, okay? Or you can say that a gradient for this line, okay? Now, we first of all, our job is to calculate AB. AB is equal to OB minus OA. And OB, when written in column factor form, turns out to be minus 716, and then A 2, 3, 5, and AB becomes equal to minus 9, minus 2, and 1. So AB will act as a direction vector for me. AB will act as a direction vector for me. O is the reference point, and I will use A as my fixed point and P as my general point, okay? P is my general point, and R is the position vector of P. P is the general point which moves all along this red line L, okay? Now, AP is equal to lambda times AB, where lambda is a scalar multiple. Where lambda is scalar multiple. And when lambda is equal to 1, point P is over here at the position of B, okay? I represent it by the point P1, okay? When lambda is 2, P is at a position which is exactly double than AB. AP2 is double in length than AB, okay? And when lambda is 3, P is somewhere over here. So that means as lambda changes, P traces out this red line, and AP is equal to lambda times minus 9 minus 2 1, okay? And now OP is equal to OA plus lambda times AB, or I've missed one step. OP is equal to OA plus AP, and then it's equal to OA plus lambda times AB, okay? And OP is equal to OA plus lambda times AB. OP is R, and OA is equal to 2, 3, 5, and AB is equal to minus 9 minus 2, 1. So this is the vector equation of a straight line in 3 dimension. And as we noted that we can write this vector equation in variety of formats. We can write this vector equation like 2 minus lambda comma 3 minus 2 lambda comma 5 plus lambda comma. We can also write it like this: 2 minus lambda I plus 3 minus 2 lambda j plus 5 plus lambda k. And we can also write it like this: 2 minus lambda, 3 minus 2 lambda, 5 plus lambda. And we replace our 2 minus lambda, 3 minus 2 lambda, 5 plus lambda. X is equal to 2 minus lambda, y is equal to 3 minus 2 lambda, and z is equal to 5 plus lambda. So when the equation is written in this format, we say we write all these three equations as parametric equations of straight line. Parametric equations of straight line in 3 dimension. We can make lambda the subject from each of these three equations, and we can write it like this. And this equation is called Cartesian equation of straight line. This equation is called Cartesian equation of straight line. So we should be able to quickly convert one form of vector equation into another form. We should be expert in it, okay? This is the topic of P3 vectors, okay? P3 vectors begin uh, by this topic of straight line, okay? We will focus our attention to a question which is particularly connected to P3 as well as to further mathematics. So we are going to do the question number 4 of exercise 6b. Question number 4 of exercise 6b is a good question in this regard, that it is also included in P3, and it is also connected to further mathematics 1, and will help us to strengthen our concepts of vectors. Okay, I'll start this question, and we will inshallah do post-mortem of this question today. It says that there are 3 points. A is 2 to 1, B is 1 comma 0 4, and C is 2 minus 3 1. Okay, the question is, find the shortest distance between the point C and the line through A and B. The question is, find the shortest distance between the point C and the line through A and B. Give your answer. Answer in the form A under root B over C. Okay. Give your answer in this form. So this is our question of today. We will try to do this question by at least 6 methods. We will try to do this question by at least, not at least, I should not say at least, we'll try to do this question by 6 methods, okay? And as we'll go through those 6 methods, it will consolidate our concepts of vectors, okay? So method number one, yeah, approach number one. Before I write method one, I should write the procedure which will be applicable to the rest of the methods. I should write the general steps which I will use in all of the 3 methods. I have to find the equation of this green line. So I first of all find the equation of this green line. AB will act as a direction vector, okay? AB is equal to OB minus OA. OB is 104 minus OA 221. This is equal to AB. Okay, AB is equal to -1 minus 2 3, and this is point C. The coordinates of the point C are 2 minus 3 1. Okay, and our job is to calculate this purple distance. It is this distance that we have to calculate. Okay. First of all, we will find the vector equation of the straight line, this blue line, which passes through AB. A and B will act as the direction vector. Vector AB will act as a direction vector, okay? So we assume a general point over here, and O is our reference point. We know that OA plus AP is equal to OP. So OP is equal to OA plus AP. And OA is 2 to 1. And AP is lambda times AB. And we call OP as R. Okay, this is the equation of the line which passes through AB. We can also represent it like this. Okay. Now, line LAV, line which passes through AB, is this. And we have to calculate the distance of C from line AB. The very first method that we are going to use, method number one. Method number one, okay? Method number one is use of distance formula. Use of distance formula. What is the use? How we use distance formula? You know that in this line AB, which passes through point A, which passes through point B, its general point P is equal to 2 minus lambda, comma 2 minus 2 lambda, comma 1 plus 3 lambda. These are the coordinates of general point on the line. We can work these points from this equation. 2 minus lambda, comma 2 minus 2 lambda, 1 plus 3 lambda. Okay. So P, the coordinates of point P are written over here. I erase this point A for simplicity because I don't want this P to be point A or B to create any problem. Okay. Now, as the lambda changes, P moves on this line. Okay. Whereas C is over here. Okay. The distance between P and C can be calculated by using distance formula. If you remember, you know from your previous knowledge that if x1, y1, z1 are the coordinates of one point and x2, y2, z2 are the coordinates of other point, then distance between them can be calculated using this famous distance formula. This formula used to be like this in O level, and when you studied three-dimensional geometry, you added another term. Okay, with addition of this third term, with addition of this third term, the distance formula takes this shape, and it's quite similar to one that we studied in O level. Okay, now we calculate the distance between PC by applying the distance formula. Okay, so PC is equal to 2 minus lambda minus 2 whole square, 2 minus 2 lambda plus 3 whole square, 1 plus 3 lambda minus 1 whole square under root, like this. And PC square is equal to, it's equal to minus lambda square, 5 minus 2 lambda square plus 3 lambda square. And PC square is equal to lambda square 25 minus 20 lambda plus 4 lambda square plus 9 lambda square. And PC square is equal to 14 lambda square minus 20 lambda plus 25. This is an expression for PC square. Okay. Now you should note that as the lambda changes, P keeps on changing its position. P can be here, it can be here, it can be here, it can be anywhere. Okay. And you know, the PC that we want to calculate, the PC that we want to calculate is the minimum. We are not interested in any other value of PC. We want to calculate this distance, this red vector indicated by this red one, which is shortest of all. Okay. So that means we want to calculate the smallest value of PC. P, where a P can change its position, it can move all along the line. And when P is right over here, then the value of PC is minimum, and we are interested in only in this minimum value, which is the shortest perpendicular distance. In order to calculate its minimum value, we can apply the method of completing square. Okay. Now completing square is equal to what? G. Completing square is equal to what? We take 14 common, it's lambda square over 10 over 7 lambda plus 25. And then, we add the square of half of this number. We add square of half of this number. That means 5 by 7 square, okay? That completes the square. And since we have added it ourselves, we have added this quantity ourselves, we have to subtract it. But bear in mind that this quantity is being multiplied by 14 as well. So we have to subtract 14 times 5 over 7 square. And this 25 will also be written over here. And now 14 is equal to lambda minus 5 by 7 whole square minus, when we simplify it, it becomes equal to what? It becomes equal to, if you have a calculator with you can see 25 multiplied to 14 gives you 350. And when 350 is divided by 7, it's 50 by 7 plus 25. I hope you understand it, and kindly check if I may not have done any mistake. Kindly check it, beta. 25 multiplied by 7 minus 50 is equal to 125 over 7. And you know, this red value is the minimum value of the expression. Hence, minimum value of PC square is 125 over 7. And PC is equal to 125 over 7, or 25 into 5 over 7 under root, and it becomes like this. So this is the minimum smallest distance, shortest distance of a point C from the line passing through point AB. But I want you to see it, and if there is any, kindly go through it carefully, and if there is any mistake, please do tell me, then we can rectify it. जी बेटा.
सर जो क्वेश्चन है उसमें जो डिनोमिनेटर है उसमें स्क्वायर रूट नहीं है सर.
अच्छा जी, आप लिसन, अब आप काइंडली चेक करें इसमें कैलकुलेशंस में मैंने की गलती तो नहीं की. मैं जो हूँ वो
नहीं सर, वो मतलब वो ये कहने का मतलब है कि आपने जो आखिरी किया है ना तो उसमें मतलब आपका नीचे स्क्वायर रूट 7 आ रहा है ना, तो उसको मल्टीप्लाई करके ऊपर ले जाए, फिर उस तरह आई थिंक सही हो जाएगा.
ऐसे.
जी
Is
सर.
this what you want to say?
जी सर बिल्कुल.
ठीक है, लेकिन आप प्लीज चेक भी करो, ये ना हो कि हमने कोई गलती की हो. सैफी मौजूद
जी
है?
सर, बुक में भी यही आंसर है. सर बुक के पीछे भी यही आंसर है जो आपने निकाला है.
चलो ठीक है, फिर तो हम चलते हैं, फिर तो हमें तसल्ली होगी ना. चलो ठीक. आए जरा chapter 2. For method 2, we will change the ink. We will do the method 2 in green, in blue. Okay. It's still the same line with the points A and B over here and C over here. And we want to calculate this smallest value of PC. Okay. We have already obtained PC. PC square. PC square was equal to what? PC square was equal to lambda square 5 minus 2 lambda plus 3 lambda square, 9 lambda square. No, my desire is the smallest value of PC. Wherever PC will get its minimum value, PC square will also get its minimum value. Okay. What we will do is that we will, in order to calculate the minimum value of this, as if I plot PC square, if I plot PC square with respect to lambda, I'll get a curve like this. And I am interested in calculating this smallest value of PC square. For this, I should differentiate it. I should take the derivative of PC square and equate it equal to 0. That will give me the lambda value of lambda, which makes this expression minimum. Okay. So we differentiate it. D times PC square over D lambda. It's equal to 2 lambda plus 2 into 5 minus 2 lambda into minus 2 plus 18 lambda. We simplify this equal to 2 lambda minus 20 plus 8 lambda plus 18 lambda, which is equal to 28 lambda minus. Putting it equal to 0, first of all, let's get it into its color. I wanted to do this whole equation in blue, method in blue. So over here, I'm changing its color. Okay. Now put this d PC square over d lambda equal to 0, and lambda is equal to 10 over 14 or 5 over 7. So we will insert this value of lambda over here. This will give me the minimum value of PC square of PC square is equal to 5 by 7 square plus 5 minus 2 into 5 by 7 whole square plus 9 5 by 7 square. Now if we simplify it, I think we will arrive at the same point. 75 minus 10, 25 square over 7 square plus 25 into 9, it's 175 over 49. And this is also equal to 49. So when we simplify it, it's 625 plus 175 plus 25 over 49. And it is equal to 825 over 49. And when you take the square root of this, PC comes equal to 825 over 49. And I think it's equal to 25 into 35 over 49 under root. And is this what we have calculated earlier? Perfect. Okay. And now we should convert everything into blue so that we can see that our second method, we can note that second method is purely done in blue. G, beta. Anything you want to ask, beta? Any problem? G, beta. And beta, is there any problem?
No, sir.
Oh, okay. Okay. Method number 3. Method for method 3, we will use another approach. Okay. Simple trigonometric approach. This is the line. A is the point over here. 2 to 1. B is this point. 1 0 comma 4. And this is C. 2 minus 3. Now AC is a vector. AC is a vector of interest. And AB is also a vector of interest. We will calculate this angle theta by applying scalar product. We will calculate this angle theta by applying scalar product. AC is equal to 0 minus 5 and 0. I hope you understand this thing. I have just written this thing. AC is equal to O minus OA, and OA is equal to 2 to 1. And this thing becomes equal to 0 minus 5, 0. Similarly, AB we have calculated earlier, and I will just write its result. This was AB. Now we know that cos theta is equal to AC dot AB divided by AC's magnitude and AB's magnitude. This is how we calculate dot product or scalar product. Now AC is equal to AC dot AB is equal to minus 1 multiplied to 0 plus minus 2 multiplied to minus 5 plus 3 multiplied to 0 under root. You can see I have multiplied this value with this and I have written it over here. Okay. Then I have multiplied this with this and I have written it over here. And then finally I multiplied this with this and I wrote it here. And then the magnitude is here. And then the magnitude of this is written over here. Now when we simplify it, it becomes 10, 5 under root 14, 2 under root 14. And if somebody can help me with the angle theta, okay, theta is equal to cos inverse of 2 over under root 14. Instead of actually calculating this angle, we just need the value of sine theta. We know that sine square theta plus cos square theta is equal to 1. Hence, sine square theta plus 2 square over 14 is equal to 1. We bring this value over here. And then sine square theta is equal to 1 minus 4 over 14 or 10 over 14 or 5 over 7. And sine theta becomes under root 5 over 7. Okay. Now we want to calculate this distance, this red distance. Okay. We call this point as D. Call this point as D. Okay. Just give me 1 minute. Just give me 1 minute. Yes, Assalamu alaikum. जी sir. बेटा वो प्रिंटर उठा के वहां रखिए प्रिंटर वाला बंदा अच्छा सॉरी बेटा I had to answer an urgent call. अच्छा this is sine theta. Now CD is equal to what? CD over AC magnitude is equal to sine theta, and CD is equal to AC sine theta. Now AC the magnitude of AC is equal to 5. So CD is equal to AC is equal to 5 and sine theta is equal to under root 5 by 7.
सर यही
5
चीज हम
under
cos थीटा
root
के साथ नहीं कर सकते थे?
when we simply जी
यही
cos के
चीज हम
साथ किस तरह
cos
से
के साथ नहीं कर सकते थे?
no cos would have helped us to calculate AD. We want to calculate CD.
अच्छा ओके सर, ठीक है, ठीक।
We want to calculate CD beta. Okay. Okay. We want
सर
to
वो फिर जब
calculate
एडी आ जाता तो फिर हम पाइथागोरस से भी कर सकते थे।
जी पाइथागोरस से भी कर सकते हैं। जी पाइथागोरस से भी आप सही कह रहे हैं। अच्छा